Okay, y'all. We're looking at two more examples of momentum, just the basic concept itself. So this example two, let's read it. We've got baseball with a mass of 0.14 kilograms is moving at 35 meters per second, and we need to find the momentum of the ball. So that's relatively straightforward. We're just going to go ahead and write our variable list. So find the momentum. That's momentum is equal to, we've got our mass, 0.14 kilograms, and a velocity of 35 meters per second. This one's pretty straightforward. We're just going to go ahead and say momentum is equal to mass times velocity. And we're going to plug it all straight in. So it's 0.14 times 35. And that will give us 4.9 kilogram meters per second. Okay, now that one was pretty straightforward. The next one is a tiny bit trickier. Let's take a look at it. In this one, we're supposed to find the velocity of a bowling ball this time. And the velocity of a bowling ball. And that bowling ball has a mass of 7.6, and the momentum is the same as the baseball. Okay. So this one is tricky in the setup. We just got to make sure we've got the right thing going for it. So in this case, we're looking for velocity. We got the mass of the ball is 7.6, and the momentum is the same as the momentum of the baseball. And we already know the momentum of the baseball because it's what we did last time. So we're looking at 4.9 kilogram meters per second, and this mass, that was 7.6 kilograms. So from here, momentum is equal to mass times velocity. We're looking for velocity, so we have to rearrange. Mass is being multiplied, so to get rid of it, we move it to the other side by dividing. Cancel. We're left with momentum over mass is equal to velocity. So we're talking about not 7.6, the momentum. Always got to make sure you're grabbing the right number. That the momentum divided by the mass, and that will equal 0.645 meters per second. And that is our velocity of the bowling ball. Notice the really big difference between this value and that one, okay? Really showing you the effect that the mass can play on something. One more example. Okay, this will be a little bit different. We've got some things we got to think about with it. Okay, so before we get too far into this, I'd like for you to remember this symbol right here, the triangle. That triangle means change, and when the math for doing change is final minus initial. So if we're going to look at problem A, it says we've got a 50 kilogram, half kilogram water balloon. It's thrown against the wall going 32 meters per second, comes to a stop, and want to know what is this change in momentum. Okay, so we're going to have to kind of think about and extrapolate what this thing is talking about. Okay, so we know that momentum is equal to mass times velocity. But the problem wants us to solve for the change in momentum. So if we're talking about the change in momentum, that means basically final minus initial. Then what's going to be the change on the other side of the equation? Mass is going to be the same, so what changes is our velocity. So what that's going to give us is this. So delta P is equal to m delta V. And we can break this up a little bit further by breaking down that delta over here. V final minus V initial. Okay, so that is how we would find, if we're looking for the change in momentum, That's what we're going to be looking for. So let's do our variables. There's that mass, is 0.50 kilograms. The velocity in here. Now we have to have a final and an initial, which means I have to have a final and initial velocity here. All right, so the initial was 32. And the language comes to a stop, tells me that the final is 0, and we're looking for delta P. So I'm going to come over, put this information in over here. So we're looking at 0.5. Our final velocity is 0 minus our initial velocity, 32. And this gives us negative 16 meters per second. Whenever your momentum decreases, it's always going to be a negative. So that is our A. Momentum, change in momentum is going to be negative 16. Now B is a little bit different. Let's take a read through on that. The green pen. We're going to go ahead, change the color here. There we go. So in this case, it's the same ball, and it's still being thrown at 32 meters per second. The difference here is that it is bouncing back with the same speed. How does this change in momentum compare to that of the water balloon? So I want to draw this out just so you can kind of see what's happening. So let's say, here we go, here's our wall, and we have a bouncy ball, and the ball is going towards it at 32 meters per second. Okay. And then it bounces back at 32 meters per second. Okay. What we have to remember in here, this is the place where it gets tricky. Is that remember, velocity is a vector, momentum is a vector. So we have to pay attention to the negatives. The thing about momentum is that momentum by itself is just mass times velocity. It's not that interesting. But it gets super interesting when we change momentum. That's where we're going to see a lot of the big ideas come through, where we're going to see a lot of the practical applications of momentum. So for right now, we're kind of bridging up from plain momentum to the change of momentum. Okay, so it's going to start getting interesting. But you have to remember that with the change in momentum, it's the sign is going to be the tricky bit. So let's fill out what we got. So we've got, it's the same mass for this scenario, same as that water balloon. That's a bouncy ball. And if it is thrown at 32 meters per second, that means our initial velocity is 32, right here. And it bounces back at 32. Okay, now think about this. If we did final minus initial of this, it's going to be 0, isn't it? Take a look at the picture. On the bounce back, which way is it going? It's going to the left, which means our final velocity is not just 32. It's got to be negative 32. Okay, pay attention to direction. Initial velocity is positive because it's going one way. Final velocity is negative because it's going the opposite. And we want to find our change in momentum. Okay, so put this all together. Change in momentum is equal to mass times delta V. Mass times delta V becomes mass times final velocity minus initial velocity. Plug it in. Our final velocity is negative 32. Our initial velocity is 32, so it's negative 32 minus positive 32. And that becomes 0.5 times negative 64, which is negative 32 meters per second. Now that's the change in momentum, but that is not the answer to the question, because it says, how does it change in momentum compare to that of a water balloon? So now that we have the two, we can see that when it bounces back at the same speed, that number right here is basically double this one, okay? So compare, So the change in momentum of the ball, something happened there. Sorry, pin issues here. Change in momentum of the ball is greater than actually, speak clear. Change momentum of the ball when it bounces back is greater than the change in momentum when the water balloon just stops. Okay. And that's our third example. After this, you need to work on the homework assignment. Just 1 second. Okay, here's the homework assignment. You'll be pass this out. It's actually on your page. It's all on one. This is what we're doing. The first 5 are relatively simple. Watch out for number 4. Know that it's asking about the, hang on, that it's asking about the weight of something. So you're going to have to go back and look up what weight is and how do I find it. Number 5 is kind of the same thing. If you look at the 6.6 newtons, what is that? That's going to be the weight. So it's going to be related to number 4. Watch out for that. Also, be careful in some places because they don't always give you the, some of the problems don't always give you a velocity. Okay, so take a look at this problem right here and a couple others. They don't actually give you the velocity. At least the final velocity. Wrong one. That's what I was looking for. Number 7. Take a look. They don't always tell you what the velocities are, so you're going to have to use another method to find the velocity. Hint, kinematics. So this will be due our next class period. Also know that the next class period, we will be having a 3-question quiz over this topic. Talk to you later. Bye.